Hi guys, welcome to the channel Academia e-Learning. Just gonna help you out with this specific question 4. It's a past paper for June of 2023. If you haven't watched all the previous questions that I just did, check them out in the description of this video or the comment section. If you're watching from TikTok, check it out from the comment section. If you're watching from YouTube, comment section also, or the description of the video. So this is what I'm going to do because there are restrictions in TikTok. I can only do a video of a maximum of 10 minutes. So I'm just going to do this video for at least less than 10 minutes. I'm going to separate it. So I'm going to do this first section here. And then in another video, I'm going to do the next section. So just note that the second video, hence I write number 2, is going to be on the description of this video. So I'm just going to do this first section here, and then we'll continue from that. So now let's solve this problem here. So we have 4.1. If you take a look, this is an exponential function, right? How do you see an exponential function? An exponential function is y is equals to a b to the power of x plus q, and it has only one asymptote, and that is a horizontal asymptote, which is q. So you need to know that. And this value of a tells you the shape of the graph. This also contributes to us telling you the shape of the graph or how it looks, whether it's increasing or decreasing, right? So that is an exponential function. So 4.1.1, we are asked on whether or not this function is increasing or decreasing. So as I said, the shape and the slope of a function, or should I say whether it's increasing or decreasing, these are the two important things, a and b. They tell you about that. So for a function that is, for example, this function here has a, which is what, greater than 0. So a is equals to 1, by the way. We have p is equals to 1 over 3 to the power of x, and a is just here, as I've written in the standard form. So a is just here, and it's 1, even though you can't see it. So 1 is greater than 0. So, and then b is greater than, what should I say? It's greater than 0. Or should I say it lies between 0 and 1? Let me just put it that way, not confuse myself. So b lies between 0 and 1. Hence we have 1 over 3, right? So if it lies between, so if you have something like this, where b lies between 0 and 1, and our value of a is 1, which is greater than 0, therefore it confirms that the function is decreasing. Check your books, but it's a decreasing function, and these are the reasons that I'm stating. Is that's what you're going to do. You're going to say a is greater than 0, which is actually 1. B lies between 0 and 1, hence the function is decreasing. So these are just the properties that you need to note. So now we're going to do the second part of, so now it's 4.1.2, right? So 4.1.2 says that determine the inverse of the function, basically p to the power of minus 1. So how do you find the inverse? We have p of x is equals to 1 over 3 to the power of x, right? Which is literally y is equals to 1 over 3 to the power of x, right? So remember, in the inverse we interchange x and y. So where there's y, we put x, and then where there's x, we put y. And then if you know logs, then you know that logs are, you have y is equals to the log, and this is the base, and this is the function. I'm just going to say function here, right? So meaning, by looking at this, you know it's y is equals to log. What is the base? It's 1 over 3, right? So it's 1 over 3, and then the function is y, right? What am I doing? The function is x. Hope you guys correctly. The function is x. So y is equals to log of base 1 over 3, the function of x. So that's how we do our inverse. Remember, we have to write it in terms of y. Y is equals to. And then now we go to the next question, which is 4.1.3. What is it saying? I hope you guys understand. If you don't, please let me know in the comment section. 4.1.3 says that write down the domain of the inverse. Okay, so I want you to tell me this before I even tell you the answer, because it's really important. Say you have a function like this, an exponential function like this, right? It's just a normal function. I'll say y is equals to, should I say x? I don't know, not x actually. Let me say 2 to the power of x, right? Let's just say that. Let's say this is the function, right? And then you're asked to find the domain. Domain, we look at the x values, right? We look at the x values. So if the x value here is positive, we know the x value here is negative, right? So we look at the x values, the movement of the x values. The function starts from a negative infinity, we know that, right? For the x values, it goes to the positive infinity for the x values. So someone can just say x is the element of real numbers, or can write minus infinity to positive infinity for the domain. You'd be correct. Now, the question says that write the domain of the inverse. So if you were to write the inverse of this, we all know that you need to draw this line here, and then the inverse will look like this, right? So now the domain of this inverse, let me just say it's p to the power of minus 1, just for control. Let me not say p, let me say it's f to the power of minus 1. Excuse me. So if we were to write the domain of this inverse, the domain of f, right? We look at the x values, remember the domain. So here it's 0. So meaning this function starts just above 0 to whatever infinity that is positive for the x values. So if you were to write the domain here, you're going to say the function starts x is greater than 0. Let's just say that x is greater than 0. It doesn't touch 0. So this would be the domain of the inverse. Hope I'm making myself clear. So this should tell you that basically the domain of the function of p of x is basically this one. X must be greater than 0. So that is the domain. I hope we are clear. The answer to this question here is this answer here. X is greater than 0. So anyways, let's continue now. We're going to do 4.1.4. I don't know how long did I spend to get here. I just hope it's not above 10 minutes. Anyways, write down the equation of the asymptote of p of x minus 5. So we already know p of x, right? It's equals to 1 over 3 to the power of x. And we know, as I said earlier on, that an exponential function is only one asymptote. Oh, yes, one asymptote, which is the y value, right? The horizontal asymptote, right? In this case, it's 0 because there's nothing here. Q is 0. We are not told. Remember I said y is equals to ab to the power of x plus q is our standard form of an exponential function, and this is our asymptote, which is the horizontal asymptote, right? But in this case, it's 0. There's nothing. So we are asked to write down the equation of the asymptote of p of x minus 5. So basically p of x minus 5 is equals to 1 over 3 to the power of x minus 5. And to write down the equation of the asymptote, we're just going to say y is equals to minus 5. That is the asymptote, the horizontal asymptote, by the way. So we are done solving this problem here. Just note that I'm done with this video. I'm just going to continue on another video for 4.2 going downwards. So please watch that. Check the link on the description of this video or the comment section if you're watching from YouTube. If you're watching from TikTok, just browse through. You'll find the video. Or check the comment section. I don't know if I'll put it. Anyways, please follow from TikTok. Please subscribe from YouTube. Thank you so much. Take care.